Greetings, good people. My name is SK Chomba from Atlanta Property Developer Limited, and I want to introduce you to another project that we are doing in Kajiado County, a place called Kitengela Ostrich Farm. This is a suspended slab. The client saw the suspended slab that we did at Konza City, and this was the right thing to do here because of the nature of soil. Because I always say that when you're doing the foundation, there are two determining factors: the topography of the soil and the depth of the maram. So it's very important to also look at that before you start any project. So we are doing the suspended slab. We started it this is the third week, and we are almost now laying the beams and blocks in preparation for the casting of the slab tomorrow morning. So I'll take you through to the same process we did last time. Now here we are. We are doing the final finishing, so that now final preparation, so that now we can be able to cast tomorrow. So these are suspended slab, and what I did, what we did from the initial stage, we dug the trenches for the columns, the bases and the columns, as we did even the other video. From there, we did the casting of the bases, casting of the columns. They are called T1s now from the ground, and then now we build the foundation wall around the outer wall. We only do the outer wall just to prevent rodent from getting into the beneath the house, and also storm water. As you can see, even the other structure, like the beam, they are flying beams. They don't have any support in terms of the walling. So that's what now we have done. We also breeding the columns. It's very important to breed the columns, so that now you can be able to have the monolithic strength of the concrete, or rather of the column. So as part of the preparation for the final casting of the slab, the foundation slab, we're also doing the breeding, or rather the overlapping of the columns. So this also, it's very important as far as structural detailing and structural aspect is concerned. Remember, a mansionette will function because of the columns and beam. So it is very important to ensure that every structural detail is adhered to as specified by the structural engineer on the approvals. Now, if maybe you can be able to zoom it a little bit, we have two steel bars, this one and this one. The one that is cut here, this one is a T1. T1 means it came from the base. Remember, we had a base, we did a concrete for the base, we joined it with this column, and then it came all the way. We have also a beam here, a concrete beam, and then it came all the way from here. So when you're overlapping with the one that is going to be now the column for the ground, for the slab, for the shutter, ensure that you overlap. The overlap is about 2 feet. That is about 600 mm. And most of the engineers I know, they know about it, and that's how they always detail. But it is very important to ensure that the overlap is about 600 mm. And now there is also this small part here that you are able to see that it has a bend, or rather it has a crank. So when you are joining these two columns, it is very important also to have this crank. Now the function of this crank is to form sort of a furnace. You see now it is very shallow on this part when it is joining, and it is straight on that part. The importance of it, moment of structure, or rather, when I talk of moment, I'm talking of the load. Load moves or trickles down through moment. It's like water, so it trickles down through moment. So when you create this sort of a furnace, you ensure that the load, or rather the moment, is well furnished to now the existing column, or rather the T1, so that now it can be trickled down out to the base. So the importance of this crank is to ensure that the load doesn't now spill. The load doesn't spill to the corners, or rather to the edge of this column. It will be squeezed a little bit. You know how the furnace looks like this one. So it will be squeezed a little bit. So now you can be able to join now or the rest of the columns, and then now it continues. Now the moment continues. The transfer of load starts from the slab. It goes to the beam. Now from the beam, it moves now to the columns. From the columns now, it will go now to the foundation, where now you have your base. So if the bases are not well done, then there is going to be a problem. If the columns also are not well done, it's going to be a problem. So the moment or the transfer of load, moment is the transfer of load. So the transfer of load will always go through, not through the wall, because most of the wall, even the precast panels or the bricks, they are non-load bearing. Then they don't carry any load, apart from the natural stone. Now the foundation stone, at least they are well compact, because it's sort of a rock. They can be able to bear the load at a specific capacity. So we are working on that, and now after we have now finished laying the beams and blocks, now we are going to lay our BRC. The most effective, or rather the most described BRC is T98. You can use T98. You can use a T142. So, but the importance of the BRC is to ensure that there is a compact in between the concrete. It provides the tensile force, whereas the concrete now provides the concrete force. So it combines to ensure that even the slab, that the concrete that we are topping on top of our beams and blocks doesn't crack. That is the importance of it, because also the beams, there are tendons on it, well pre-stressed. So we are almost done with the preparation for tomorrow, because tomorrow we are doing the casting. We have also fixed the steel bar, because of the columns that is going out to carry the load from the ground, from the slab. Now, a very important thing when you're doing the steel work, you see these two steels here. The first one is a T1 that came all the way from the base, from the foundation, now from the base, and we terminated it here. And then now there is this one, the addition of this one, now the overlapping one, that is now going to form the part of the column that is going up. And you can realize that there's a crank, or rather sort of a, yeah, it's a crank that has been done here, because you normally do this when you are combining the two steel bars. The reason behind this is, if you pull them all together and you do the formwork, the column will not be straight. It will have some, the column, the concrete will not be straight. It will have some gaps in between this one and this one, because now this one have overlapped, or rather it have overlapped the other one. Secondly, the second reason as to why we have done that, we cannot do a smaller ring. This is the ring. We cannot do a star ring, a smaller one than this one. That is very important. So if you put your formwork here, it's even, it's going to be straight, because of this crank that you've done. So the crank is to ensure that the whole of this column now covers with this one, so that now when the load moment, when we talk of the moment, we are talking of the weight, the load. So the load of the load that will be carried by this column will be evenly distributed, because now the concrete will be the concrete for this column will be also even. So that is very, very important. From there, we have done our BRC. After now laying successfully laying the beams and blocks very well. We've took all the levels, so we've laid the BRC. One thing that we've not done, and we are going to do it because we are disturbed by rain, we are going to have some pegs in between in between the beam and the block and the BRC, so that we allow the concrete to be underneath the BRC. So those are the things that we are going to just do it tomorrow morning. We have also done our piping for the the plumbing works for the toilet, where the toilet will be and where the kitchen will be. So that's all. We have done it. This is a very successful suspended slab. The cost of this was about 890 compared to the other one that we had, because the previous one that we had done the convectional one. The convectional one was about 1 point something, 1 point, or I think 1.1, 1.12 something. So there's a saving of about 300,000 overall. So my take on the foundation, I think depending on the nature of the soil and the depth of the maram, I think suspended, it's coming along well in terms of saving, very doing it very fast, and also in terms of now the stability, because you cannot compare the suspended slab with the convectional one, because we have multiple columns which we could not have had if we were doing the convectional one. So what we have done on the convection, we've just added the outer walls, also acting as part of the supporting system of the beams and blocks, or rather of the suspended slab. So we are done. On Monday, after we've cast tomorrow, on Monday now, we have our panels there ready. So we are good to go. We hope to feature this maybe in the next couple of weeks to see how the progress is. Thank you very much, and see you on your project.